or good morning, good evening, whatever time it is when you're watching this. So today I am making uh, doing the Unit 2A assessment. So this is Unit 2A. And so let's go ahead and get our screen set up, full screen. And so let's get started. So let me do one more thing. I'm going to get my calculator over here across the room. So you should have your calculator out. You should have your test out. I'll also include a link to a blank copy of this test. And you should be working through the problems. In fact, you should try the problem first by pausing the video and going as far as you can, and then allow the video to play to see if you did it correctly. And for the problems that you are having difficulty with, once you watch them being done, you should do them over multiple times on a separate sheet of paper until you can do them independently without watching the video, without looking at any notes. Remember, as I always say, you learn math by doing, not by watching, okay? So let's get going. Number one, solve the equation, write a justification for each step. So basically, we're looking for justification for this step here and for this step. So all we do is first look down at our answer choices and so, oh, it's like, okay, we're looking for properties. So now, what property was used in this very first step? Well, what is the math that's being done? We added the same number to both sides. And so that's going to be your division property. And then here at this line, what were we doing? We divided both sides by 2. And, all right, so we're dividing both sides by 6. And so that is the division property. I'm sorry, and I see I wrote this wrong. I should have written addition property here. My apologies. So number 1 should be addition property, and number 2 is division. That leaves us B for the answer. Let's look at the next problem. Solve the equation 5y plus 1 equals 2y minus 14. So our goal is to get the y by itself. But the problem is I have y's on both sides. So I have to group them together. But what we're doing is we're rearranging the problem so that all my variables are on one side and my constants are on the other. So you have to get rid of whatever's on the wrong side. So I decided to get rid of the 2y, and by getting rid of it from one side, it gets moved to the other side, or we subtract it from the other side, I should say. And so I end up with that. And then I need to get this 1, get rid of this 1. So by doing that, I end up with negative 15. And now I can use my division property, divide both sides by 3, and I get y equals negative 5. C. Number 3. Let me extend my page a little bit. Okay, solve the system. Oh, systems of equations. So we have negative 6x plus 6y equals negative 4. And the second part of the system is 2x minus 2y equals 5. So I want to do elimination here. You could also do substitution. You could also solve this by graphing. If you were using a graphic calculator, you could do that as well. But we want to do elimination here because really you wouldn't have access to a graphic calculator. So I'm looking at my x's and y's, and it really doesn't matter which one you eliminate. It's the same work either way. So I'm going to multiply the second equation by 3. And so now the first equation remains the same. The second equation, everything in here gets multiplied by 3. So we get 6x minus 6y equals 15. And something really interesting happens here. The x's cancel out, the y's cancel out, leaving me with 0 on the left and 19 on the right. This does not make any sense. 0 does not equal 19. That means there's no solution. No solution. Number 4. So it says if 3a minus 9 equals 6, then what is the value of 5a plus 2? So we really want to know. The question is, what is 5a plus 2? Well, I don't know what that equals. I cannot figure out what that equals unless I know what a equals. So the question here is, what does a equal? So I look back at the problem and I'm told that 3a minus 9, let me get rid of that. I don't know why that's there. Okay, 3a minus 9 equals 6. Well, I can solve this for a by using the addition property, adding 9 to both sides, and then use the division property, dividing both sides by 3. A is 5. So if I know that a is 5, then 5a plus 2 must equal 5 times 5 plus 2, which is 25, plus 2, which is 27. So here is 27. Again, guys, if the problems are going by too fast, you can pause them, you can rewind them, and listen again. Do whatever it takes to get this math. You understand? Number 5. The school that Callie goes to is selling tickets to a spring musical. Let's move this out the way. And let's move that out the way. Sorry about that. Move that over there. So it says on the first day of ticket sales, the school sold 9 senior citizen tickets and 1 student ticket for $52. They took in $76 on the second day by selling 4 senior tickets and 8 student tickets. Find the price of a senior citizen ticket and the price of a student ticket. So I have to write a system, and you may remember doing a problem just like this on our performance exam. So I'm going to squeeze some work in over here. So I'm going to let X equal the cost of a senior citizen ticket. And I just decide based on what order the different things are mentioned. So since senior tickets are mentioned first, I choose to let those be represented by X. And let me erase that. And Y is going to equal the cost of a student ticket. All right. So now if you're trying to figure out how much money you're going to take in for your ticket sales, so if you were selling tickets yourself, you probably would recognize, oh, you need to multiply 9 by the cost of the senior tickets and then 1 times the cost of the student tickets and add that together to get the 52. So what represents cost? Well, X. So 9 tickets times X dollars per ticket plus 1 ticket times Y dollars per ticket gives us a total of 52 for day 1. And then on day 2, it would be 4x plus 8y equals 76. So here's another system. So in order to solve this system, I'm choosing to do it by elimination again. When you're doing a test like this, unless they tell you what method to use, you can use whatever method you want. We could have also done substitution. So I'm going to eliminate the y's, and I chose to eliminate the y's because the least amount of work is required. All I have to do is 1 multiplication, and then I have opposites because you're trying to get opposites. know what 52 times 8 is, but I have my handy dandy calculator. So that's going to be negative 416. And then this one remains the same. All right. So 72 take away 4. So it's 68, but because the larger number, the absolute value is negative, it's going to be negative 68x. These are gone. And then 416 minus 76 is 340, but it's going to be negative because the larger absolute value is negative. I want to isolate my x value, so we'll divide both sides by 68. And that's a negative 68, and a negative divided by a negative is positive 5. So once I know x, well, look, remember we said we're going to work harder, not smarter? We've said that before. This is the cost of a senior ticket. Let's check our multiple choice answers. And look, this senior ticket is 3, 6, here is 5. We're done. We are done. We don't have to do anything else on that problem. Next question, number 6, says graph the inequality. The first thing I pay attention to is, do all my graphs have solid lines? Because of that inequality, we know it's going to be solid. And then I check, and also because it's less than, we're going to shade below. And so I see that, well, they're all solid, but these two are shaded above. So then what distinguishes C and D? So as I'm looking at them, I see that the lines have different y-intercepts. This y-intercept appears to be here, and this one is a negative number. So this is at positive 2, and so I'm going to look at my graph, and I see that my equation is y less or equal to 3x plus 2. So this one has a positive y-intercept, so that's how I select that. So the point of the problem is, do you know how to shade, and do you know how to graph a line? Number 7 says if you buy a car wash at the gas station for $6, the cost per gallon is $3. If you have 40 bucks, find the number of gallons you can afford. So there are two different approaches you can take to this problem. The way I looked at it was, well, you have to buy the car wash. So if you've got $40 and you buy the car wash, that leaves you with 34 bucks. So then if you have $34 and the gas is 3 bucks per gallon, so if I do 34 divided by 3, I can buy roughly 11 gallons. It's actually 11.3 repeating. Well, so what would that be? I cannot buy 12 gallons. I don't have enough. 12 gallons would cost more than that, okay? It would cost $36. I only have $34. So I certainly can't buy 15. I can buy more than 3, but 11 is the closest answer. That is the one. All right, but the reason it's not 12 is because 12 gallons would cost $36. That's too much. You don't have enough money for that. Next question. Rambo, funny name, is solving a linear programming problem. He graphs the system of constraints to the left. What coordinates represent the possible solutions to his problem? So the possible solutions, this is just a system of 3 equations. So solutions to systems are always the intersection points. So I am off a little bit here. So here's our intersection point. All right, so all I have to do is read those coordinates. So it's not A because 0, 0 is here. There's no coordinate at 0, 0. There is a coordinate at 1, 2, 3, 4, and 2. All right, so the only one that has a 4 and 2 in it is this one right here. This also is a coordinate at 4 and 6, which is there. And then the last one here, this is 12 and 2. Okay, this is 4 and 6, and this is 4 and 2. All right, so the answer is C. All right, let's keep it moving. Archimedes is solving a linear programming problem. After graphing the system of constraints, he finds the possible solution. So these are all the intersection points. So there are four of them. And so now we want to find the maximum value. So we have to use this. The objective final, the objective function is really the the purpose of the system. What are we trying to figure out with the system? So what we do is we have to test each point and then see which one gives us the largest value. So test each ordered pair. So all we're doing is just taking these ordered pairs and plugging them in. So I'm going to use 0, 0. I'm going to use 4, 0. I'm going to use 3, 7, and 0, 9. We're going to plug them in. The first value is x, the second value is y. So we're going to plug them into 4x plus 7y, do the math, and see which one is biggest because we're looking for the maximum value. All right? So I have 4 times 0 plus 7 times 0, which is just 0. For the next one, I have 4 times 4 plus 7 times 0, which is 16. Then I have 4 times 3 plus 7 times 7. Oops. All right, so I'm going to get my calculator out. 4 times 3 is 12. 7 times 7 is 49. So that gives me 61. And 4 times 0 plus 7 times 9. Well, 7 times 9 is 72, right? Or, I'm sorry, I made a mistake. 63, that's 7 times 8. So which is the maximum value? 63. All right. Number 10. Which ordered pair is a solution of the linear system? And so let's go ahead and just solve the solution. You could work backwards by testing each ordered pair. Oh my gosh, that's so much work. I think what I'm going to do here is I'm going to solve by substitution. So I'm going to take this equation here, x plus y equals negative 2. And you can solve either for the x or the y. It really doesn't matter. So I'm going to isolate the y. So I'm going to isolate the x. So I'm going to subtract y from both sides. So x equals 2, take away y. So then I come back and I put 2 minus y in for y in the other equation. So I'm going to have 7x minus 4 times 2 minus y. And you could use elimination on this. It's totally fine. Or you could work backwards. So I made a mistake here. Let's do that again. What I did was I substituted into the wrong part. I substituted into y instead of x. So let me fix that. Okay, so I'm going backwards. And I'm going to pick up from here. So I'm putting this in place of x. My apologies. So the reason I caught my mistake was because once you substitute for one of the variables, then you should only have one variable. You go from 2 equations and 2 variables to 1 equation and 1 variable. But when I did my substitution, I still had an x and a y, which let me know, uh-oh, I made a boo-boo, I made a mistake somewhere. Okay, so now, look, I only have y's. If you only have one variable in the equation, then you can solve for that variable. So I do have to do a little math. So this is going to be 14 minus 7y minus 4y equals 8. So we'll have 14 minus 11y equals 8. We're going to subtract 14 from both sides. And I get negative 11y equals 8 minus 14 is going to be 6. Negative 6 to be exact. And let's see. Okay, so don't be upset with me. I made one more mistake. I'm really tired. I'm sorry. I left my negative sign off. So when I did my substitution, I ended up getting the wrong answer. I'm so sorry. It happens. Real life, we make mistakes, but the important thing is, are we catching our mistakes, right? So now it's going to be correct. So we have negative 14 minus 11y equals 8. The reason I knew my answer was wrong was because I got a fraction. I was going to get a fraction for y, and none of those y values were fractions. So that let me know that something is really wrong here. So now I'm going to get a nice whole number. 11y equals 22. Negative 11y. Divide both sides by negative 11. So y equals negative 2. So the only one that has a negative 2 for the y is B. So that's all I have to do. My apologies for making that mistake. Number 11, solve the system by graphing. So the easiest thing to do in these is to put each equation in slope intercept form. Form is how something is arranged or set up. That's your y equals mx plus b form. So first we'll do 3x plus 4y equals negative 36. So I'm isolating the y, so I'm going to subtract 3x from both sides. And once I get it into this form, then I will be able to easily see what my slope and my y-intercepts are. And then I can identify the equation. And then divide everything by 4. So we get y equals negative 3 over 4x minus 9. And then this other equation is negative 2x plus 4y equals negative 16. We will add 2x to both sides. We have 4x equals 2x minus 16. Divide everything by 4. And x equals, I have to reduce that, 1/2 x minus 4. It wouldn't be wrong if we didn't reduce it. You would still be able to correctly identify your line. So I know that I have a y-intercept of negative 9 for one of my equations. And also for the other equation, I have a y-intercept of negative 4. So I've got my negative 4 here, 5, 6, 7. So I don't have negative 9, so it can't be this one. All right, that's a positive 4 and a positive 9, so it's not that one. But this y-intercept, oh, that's negative 9, and that's negative 4. That's what I want. Okay, so choice B was the correct answer for that problem, right? Okay, so moving right along. Number 12, solve the system of linear inequalities. So with this one, all the lines are graphed identically. It looks like we have some solid and some dashed lines, and that's important. But um, let's see what's going on here. I know that really all of the lines should be solid because that's greater than or equal to, all right, and so is this. So we know that's going to be solid. And this is greater than, that's going to be above. And this is going to be below because it's less than. So I need to find the lines and identify them. So we have 2x plus 4. So my y-intercept will be 4. And so now, if this is my line right here, if this is the line that we're dealing with, okay, and it's solid, we would be shading above, okay, and then the next line is this line here with a y-intercept of -2, all right, it's solid as well, but we would shade below. So this one, I was just using graph A as a spot to actually do the graphing, and I can see what the graphing should look like. So the answer is actually C. All right. So this is what it should look like, what I wrote in the red and in the blue. Okay. So I can see that this is not shaded correctly, this is not shaded correctly, and neither is this one. All right. So the correct answer is C. All right. Number 15, solve the following system. So we have another system. So we have 8x plus 8y equals 24. And then we have x plus 5y equals 11. So we could do the elimination, or we could do substitution. I don't know, for some reason I just want to do elimination. So I'm going to eliminate my x's. So I'm going to multiply this equation by -8. So the first equation stays the same. The second equation becomes -x minus 40y equals -88. So let's go ahead and do our math. So 88 minus 24 is 64, but it's going to be negative since the absolute value is larger. We have a -88. And then 40 minus 8, that's going to be 32y, but it's going to be negative, that's gone. So then I can divide both sides. So now we're going to divide both sides by -32, so we can get the y isolated. So y is going to equal +2, because a negative divided by a negative is positive. So then, technically we can figure out what our answer is just based on this. But let's just do the work and find out what x equals to confirm. So I'm going to substitute y equals 2 into the second equation. So the second equation is x plus 5y equals 11. I'm going to replace y with 2. So x plus 5 times 2 should equal 11. So x plus 10 equals 11. Subtract 10 from both sides. So x equals 1, which makes sense. That's why D is 1. So we're on the last problem. Yay! So it says the senior classes at Grayson High School and Archer High School planned separate trips to New York. The senior class at Grayson rented and filled 16 vans and 5 buses with 417 kids. Archer rented and filled oops, I can't see part of the problem here. Let's see. 10 vans and 8 buses with 480 students. Every van had the same number of students in it as did the buses. So first we want our functions. So this is just like the ticket problem that we did earlier for the show, with the student tickets and the senior tickets. So I'm going to let vans, the number of vans, or the number of students in the vans, I'm sorry, be x, and then the students in the buses will be y. So the function for the Grayson High School would be 16x plus 5y equals 417. And this next one is going to be 10x plus 8y equals 480. So it tells us specifically to do elimination, which is what I would recommend. So 16x plus 5y equals 417. 10x plus 8y equals 480. The challenge with this problem is that there's no one single multiplication that I can do for the elimination. We'll have to multiply both equations by a number. so that I can eliminate something. I choose to eliminate my y's just because they're smaller, and these smaller numbers are just going to be easier to work with. And so if you can't figure out what to multiply by, just alternate. Just multiply the top number by the bottom and the bottom by the top, and that will always give you something that will work, okay? So I'm going to multiply this top one by 8, and I'll multiply the bottom one by a -5, because remember, I am trying to make opposites. So I'm going to slide over here. So I've got my handy dandy calculator. So 16 times 8, oops, 16 times 8, I got a really big number. Okay, 128x, and plus 40y, and then 417 times 8. Wow, it's 3336. It's okay if we get big numbers. And then -5 times 10x is -50x, minus 40y, and then 480 times 5 is going to be 2400, but it's going to be -2400. So now we can go ahead and add these equations together. So by adding, sometimes I have to actually subtract if the number's negative. So 128 minus 50 ends up giving me 78x. That goes bye-bye. 3336 minus 2400 gives me 936. And I'm thinking that when I divide both sides by 78, I'm going to get a nice whole number. Bam, I get x equals 12. So that represents how many students were in the bands. Okay, so that's 12. But then I have to come back and I need to find y. So I'm going to use this answer and I'm going to substitute it. Doesn't matter which equation, I'm going to use the first one. So 16x plus 5y equals 417. So I'm going to replace this x with 12. Alright, so I have 16 times 12 plus 5 times y equals 417. 16 times 12, I have no idea what that is. 192, but my calculator is a handy tool that helps me at all times. I want to subtract 192 from both sides. So 417 minus 192 is 225, yay, divided by 5. So we're out of space, and I get 45, which makes sense because buses carry more people than vans, right? So that's it. Are we done? Have we finished? Is there any more? Aha, I was wrong. There's one more problem. So we have to complete the algebraic proof. Well, you guys are pretty good at these. So that reason is given. So I'm going to actually work the problem out. So I'm going to distribute. So I get 15x plus 3 equals 13x plus 5. So what did I do? What's the reason that allows me to do that? The distributive property. So then, now I'm trying to solve for x. So we had a problem like this on a very first page, I think, where we had to solve for a variable. And so we regrouped it so that like terms were on the same side. So if you have something that's on the wrong side, you have to get rid of it. So I want to get my variables, my x's on the left, and my constants, my 3 and my 5 on the right. So I want to get rid of the 3 and the 13. So I'm going to go ahead and take care of the 13x first. Whatever I do on one side, I do on the other. This gives me 2x plus 3 equals 5. Now I want to get rid of the 3. It's still on the wrong side. I'm going to subtract 3 from both sides. I end up with 2x equals 2. So let's see, what did I do here? I subtracted 13x from both sides. So what allows me to do that? So that's the subtraction property. And then this line right here, that's just what we call simplified. And then here, I subtract it again. I'm just drawing lines so you can clearly see. Normally we would just number them in the same sequence on the left and the right. And then this final, or this next line here, that's another simplified. That's how we got 2x equals 2. And now what am I doing? I'm dividing both sides by 2. So that's the division property. We're just writing down the rules that allow us to do the steps that we know to do. And then when I simplify, I get x equals 1. Okay. And I do believe that we're done. Thanks a lot. I hope this helps. Make sure you practice. And then when you are done making your corrections and doing your practicing, please go to USA Test Prep and I will have a benchmark code for you to do embedded at the end of the video so that you can go ahead and do your point recovery. Good luck.